where we are going to enter into the day 6 Arduino Lab session. Last class we have seen how to interface the LCD. We did few experiments. First we made the hello world statement to print. Next, how to control the cursor and blink it. Then how to set the cursor and print the statement. Then how to read the continuous values and make print in the LCD display. Finally, we've seen how to read the external environmental changes like a switch or potentiometer. So in this example, we read the status of the switch and we updated the value of the, wait a minute. Yes. Now, in today's class, as I told already, we are going to interface a relay. So we are going to do few experiment. If time permits, we will continue in the next class. Okay. The first experiment, turn on relay for 1 second and turn off relay for 1 second. So the program part is very simple. The blinking program exercise, what we have did in the very first class, the same program we are going to use it. Only the pin number we need to change. So the first exercise, make the relay to on for some time and make the relay to off for some time. The duration here we mentioned as 1 second. Then the next one is when first experiment we are going to make only the relay to on and off. In second experiment we are going to interface some output devices with the relay. What are the output devices we are going to interface here means LED and buzzer. First we will see the first exercise. After that we are going to interface the incandescent lamp. Okay. Now first experiment. Please see here. You may observe number and large components in the diagram. Don't worry about it. All are known to you. One by one we are going to connect and execute the experiment. Okay. First observe what are the things happening in the animation or the video. Please observe. Only on state and off state. Here, for clear observation, I increase the duration as 5 seconds in this video. Okay. What are the changes you are observing in this video? Only tell me that multimeter values and LED status. Yes, I will explain you once. Here we have an LED to indicate whether the relay is in on state or off state. Then I am having two multimeters. One is connected across common and NO. Another multimeter is connected across common and NC. So whenever my relay is in off condition, see, wait, let it get off. See, whenever my relay is in off condition, my NC and common is in closed path. Therefore, the resistance is 0 ohm. At the same time, common and NO is open circuit, so infinite ohm. So whenever my relay is in off condition, common and NC will be in a closed state. Therefore, it shows 0 resistance. Similarly, common and NO is open circuit. Therefore, it shows infinite resistance. In this way, we are going to ensure whether our relay is in on condition or off condition. Okay, come we will do the exercise. For that, program is very simple. Same blinking program. Instead of pin number 13, here we are using pin number 7. So configure your pin number 7 as an output. Then make your LED to logic low by default. Sorry, pin number 7 to logic low. So program pin mode 7, output, digital write off 7, low. So I am going to interface my relay with the digital pin of pin number 7. Okay. In void loop, as usual, make the pin to logic high, then create one delay, then make the pin to low, then again generate the delay. Okay. So if you convert into program, Digital rate of 7 comma high, low for high for some time, low for some time. So delay 1 second we have introduced. Now we will come to the hardware demonstration, how we will do it in this. As usual, come to Tinkercad. Is it visible for everyone? This monitor is visible, Tinkercad monitor.
Yes,
Come, sir.
Gajendran.
Yes, yes. So this is our Arduino board, breadboard. Then what else we need for this experiment means, please compare with the circuit diagram. So select all components, then start pick the elements. First resistor, then resistor, LED. Relay is an input device or output device. Can anyone type it in chat box? Relay is an input device or output device. Can anyone type it in chat box? Relay is an input device or output device? Output device. Very good. But you
Output.
search it in output. See, now I am in output menu. Let me check whether the relay is available in output. No, it is not available. Then what is the issue? Come down, little bit come down. You have another option called power control. Even though my relay is an output device, you can't find the relay in the output menu. There are another category in this Tinkercad software they given as a power control. So high current rating devices, they listed under the power control component list. Okay, in that you will find relay. See, this is your relay. There are two types of relays available, SPDT and DPDT. You may aware of this notation, double pole double throw and single pole double throw. Let me take single pole double throw relay. Okay, then what else we need? Can anyone tell whether I can connect my relay straight away to my Arduino? Shall I interface these two directly? No, because my Arduino digital input output pins capable of handling only 40 milliampere. But the relay will draw more than 40 milliampere. If I connect my relay straight away to my Arduino, it will get damaged. My Arduino board will get damaged. Therefore, I need to use any one switching device or driver element. Okay, for that purpose, we are going to use transistor. Again, in power control category, you will find two type of transistor. One is NPN, the second one is PNP. Can anyone tell by seeing the circuit diagram, by seeing the previous presentation, can you tell what type of transistor are shown in your diagram? Whether it is an NPN or PNP? Can anyone type it in your chat box? Can anyone type it in your chat box, please?
NPN, Gajendran. A lot of people
NPN.
are
Yes, NPN. See, this is the circuit diagram. We need to attain this configuration. See, I need to fetch NPN transistor. Then one more diode I need to pick from the component list. So come back. Now I need to pick NPN transistor. That's all. Then what else we need? We need a diode. We need diode. We'll go to where the diode is available. See here, you have two type of diodes. It is available in general component list, resistor, capacitor. After that, you have a diode. You have a Zener diode also. Okay, let me pick the simple PN junction diode. That's all. By the way, I have selected all the components. So we will start with the new components one by one. What are all the terminals available? Once you identify all the terminals, then you can start connect the individual things. First, we will start with the diode. Diode, you have two terminals, you know very well. One is anode, another one is cathode. So now doubt with this. So I will keep the diode here. Then come to transistor. Transistor, how many terminals are there? It's a 3-terminal device. The first terminal, see, collector. The second one, base. The third one, emitter. Okay, the first one is collector, the second one is base, the third one is emitter. Now you come to the relay. How many terminals are there in the relay? As per our the discussion, we have 5 terminals, two for coil, two for coil, and three for your contact terminals, isn't it? So now we need to identify the coil terminal as well as this contact terminal. Come here. Just bring the cursor nearby your relay. Before that, let me zoom the relay image. Can you find how many terminals are there here? One, two. See, this is one, this is two, then three, four not given. Okay, one, two, three, four, five, six. How many terminals are there? 6 terminals are there. Before that, please observe the notation here. Here, LU5R means this relay going to operate with 5-volt DC supply. You can operate. The operating voltage of this relay is 5 volt. There are two specifications you have to know whenever you are dealing with the relay. What is the coil voltage? Please make a note of it. Coil voltage is here, it is 5 volt. This 5 represents 5 volt. Then the second specification is contact current and voltage rating. So first we have known the coil voltage, we know. Then we need to know the contact specification. For this contact, you have a two notation. One is current, another one is voltage. Please make a note of it. This relay can operate 3 ampere current rating if you are supplying with 125 volt AC. If you are using AC supply in this contact terminal, the current rating is 3 ampere. Instead of AC supply, if you use DC supply in this contact terminal, again the current rating is 3 ampere. Okay, likewise, if you buy any relay, they will give two specification. One is the coil voltage, the second one is the contact specification. Contact specification always two things, current rating and the voltage. That means, see, this is where power circuit, this is your power circuit. This using this contact only, we are going to turn on and turn off the external environment loads. So those specification also we need to keep in mind, whether we are going to use AC or DC in this contact terminal. Okay, so the coil voltage is 5 volt. So if you simply connect the 5 volt across the coil will get energized. Then how to identify these terminals? Come here. For that, they given symbolic notation. Please see here. There are 6 terminals, 1, 2, 3, 4, 5, and 6. Out of all the 6 terminals, the middle terminals, this and this, please make a note of it. Terminal number 5 and terminal number 8 is your coil terminal. Is it okay? My terminal number 5 and terminal number 8 is coil terminal. Okay. Then out of 5, here we have identified 2. But here given one more terminal. Why there is a extra terminal means for common, please identify the diagram. For common, they given 2 terminals. So you can use any one of the terminal or you can use both the terminals. Okay. So terminal numbers, terminal number 12 and 1. Terminal number 1 and 12 are common terminals. Please make a note of it. I repeat once again. Terminal number 1 and terminal number 12 are common terminals. Then terminal number 5 and terminal number 8 are coil terminals. Okay. Then what else remaining? Only NO and NC. Please observe the symbol and tell me what about this bottom terminal? Terminal number 7 is NC or NO. Can anyone type it in chat box? Please compare this symbol. This is your symbol. With the help of the symbol, this middle line is your common terminal. Already we have finished. What about this bottom one? whether it is NC or NO. Can anyone type it in chat box? Whether it is NC or NO. Terminal number 7. Please refer the symbol. These two are in contact. That means what?
NC.
Very good. It is NC. It is NC. So terminal number 7 is NC. Then obviously terminal number 6 will be NO. So I repeat once again, the coil terminals are 5 and 8. Coil terminals are 5 and 8. The common terminal is, I have two options, terminal number 12 and terminal number 1. Then NC is terminal number 7, NO is terminal number 6. That's all. If you aware of these terminals, we can start do our connection. Okay, now we will take one by one. First, I am going to take the relay. Keep it in between the two column. Okay, see, in between you have some separator layer. So likewise you keep. So the bottom 3 terminals should be connected in the top portion of your breadboard. Then top 3 terminals. Bottom terminal need to be connected in the below portion of your breadboard. Okay. Now we need to start do the connection one by one. Before that, please come back to your circuit diagram. One end of the coil terminal, I need to connect it to VCC. And another end of the coil terminal, I need to connect it in series with the transistor, whether it is a collector terminal or emitter terminal. It is a collector terminal. So come back here. Please draw the circuit diagram in your notebook and follow this connection. Then only you can follow the two things in simultaneously. Okay. Now as usual, I'm going to power my breadboard first. Power my breadboard, followed by we are going to connect the remaining components. Meantime, if possible, draw the circuit diagram once, then only can familiar with the circuit easily. Okay, now, so these two are coil terminals. Terminal number 5 and 8. So terminal number 5 and 8 are coil terminals. So I'm going to take one end of the coil terminal to the VCC. One end of the coil terminal to VCC. Okay. Else we will do one thing. As for our circuit diagram, we will use the top terminal as a. Wait a minute. So top coil terminal, I am going to connect it with VCC. Okay. What about the other terminal? The other end of the coil terminal need to connect it to the collector terminal of my transistor. So this is my transistor. Bring your transistor, keep it over here. Which one is the collector terminal? This is your collector terminal. So take one wire. That's all. So VCC to one end of the coil terminal, then from the another end of the coil terminal to the collector end of the transistor. Okay. Then what? Then collector we finished. Then from the emitter, I need to connect on resistor and LED. This resistor and LED are optional. Whenever you want to identify whether my relay is in on condition, if you want some visual identification, I need to include this. Okay. So let me take the resistor. Where is my resistor? It is available here. I will keep the resistor value as 220 ohm. Okay. 220 ohm. Take the resistor. This is my where I need to connect from the emitter terminal. Okay. So this is our emitter terminal. Let me zoom once. Yes, this is our emitter terminal. So I am going to take this resistor, and the emitter, from the emitter it need to be connected to the ground. See here, this is my emitter terminal. From the emitter terminal I have connected on resistor in series. After that we need to include LED, isn't it? So I will do one thing, we'll keep like this. There you have a connection. Wait a minute, I will let me move little bit. Yes. Sorry. See, if I are connecting nearby means it is going with the going to gives little trouble. Therefore, I'm little ahead. Okay, that's all. So this is our emitter terminal resistor. Then take your LED. Please find where I need to connect the LED. Anode terminal need to connect to the one end of the resistor. Then cathode terminal need to be grounded. So take anode terminal. Take anode terminal. This is our anode terminal. How to connect? Let me keep it here. Take one end from the resistor and connect it to the anode terminal of my LED. That's all. Then the cathode terminal of the LED need to be grounded. That's all over. So I repeat once again, what are all the connections we have made so far? See, from the VCC to one end of the coil terminal, then from the another end of the coil terminal to the collector, then from the emitter terminal, I have connected one resistor and LED in series. Okay. Then the cathode terminal of the LED is grounded. What about the base terminal? Base terminal, I need to connect one more resistor. Then I need to connect it to our controller. Okay. See, this is our base resistor. Then this input terminal need to be connected to the input terminal of my Arduino. Okay. So as per our program, I am going to use the 7th pin as an output terminal for our experiment. So we'll do one thing. We will connect the resistor here. Okay. The value of the resistor must be 1 kilo ohm. 1 kilo ohm. So base is connected with one resistor. Then other end of the resistor we need to connect it to our output terminal of our Arduino. 7. That's all. Do you have any doubt up to this? Please stop me, else I will continue. What else remaining? What else remaining? So as for the coil circuit, that means the triggering part we have completed. Only the power circuit of the relay we need to wire. Before that, we need to connect this diode. We need to connect this diode in reverse bias mode. Reverse bias means what? The VCC need to connect it to the cathode terminal of your diode, and the anode need to connect it to the ground. Okay. So how to connect it? See, this is your diode. This is your anode terminal. This is your cathode terminal. Take your diode. Take your diode. So cathode terminal, I need to connect it to the one end of the coil. Cathode, I need to connect it here. Okay. So see, this is your coil terminal. I have connected my diode cathode terminal in this coil terminal. Okay. Then what about the anode terminal? Anode terminal, we need to connect it with the collector terminal of my transistor. Okay. So let me take one more wire and bring it here.
Gajendran, diagram ஒரு தடவை காமிச்சிருங்க Gajendran.
Yes, sir. See, I will once again show you the circuit diagram. Once again, I will show you the circuit diagram. See here, this is your diode. This is your diode. One end of the diode, that is your cathode terminal, need to be connected with the VCC. Then another end, anode, is connected to the collector terminal or another end of the coil. Simply, I need to connect the diode in parallel with your coil. Okay, the diode need to be connected in parallel with your coil terminal of your relay. Okay, so instead of going there, I can connect it here also. Okay, from here take one wire. That's all. So now I have connected the diode across my coil terminal. See, this is my coil terminal. This is the one end of the coil terminal. This is the another end of the coil terminal. So this is VCC 5 volt. So 5 volt cathode terminal. Then the another end of the coil we will receive the negative. So there I need to use anode. It must be in reverse bias mode. So I will explain you why we are using this diode and all. Okay. So thereby now we made the control circuit wiring is finished. Now I need to test my output terminals, that is common NY/NC, whether my relay is getting turned on or turn off. I need to check. How we can check? See, we have an instrument. Come down. We have an instrument menu. See, instrument. In that we have multimeter. See, even the power supply also they given the category as instrument. Okay. So now we will fetch multimeter from here. You very well know how to use the multimeter. Multi quantities we can measure with the help of the multimeter. Here they given three options. Ampere range is nothing but to measure the current. At that time, we need to connect this meter in series with our circuit. Second option, voltage. So parallelly, we have to connect the test terminal and we need to measure the voltage. Now, I am going to measure the resistance. Resistance between my common and NO terminal and common and NC terminal. Okay. Keep the mode in resistance mode. Resistance mode. Now we will move the circuit little bit. Only this relay portion we want. Remaining portion we are not going to bother. So yes, I need two multimeters. First, what we will do, we will connect one multimeter across common and NO point. Can anyone tell what are all the common and NO terminal names? Can anyone type it in chat box? Common and NO. Common terminals are terminal 1 and terminal 12. So I am going to connect across common and NO terminal. Common and NO. Can anyone tell what is the terminal name of NO? Where it is available? See, this is my NO terminal. Terminal 6. See, this is NO. So from the terminal number 6, I am going to connect one more probe of my multimeter. Okay, let me keep red and black. So, sorry, red and black. How simple it is. See, common to NO. For your better understanding, I am going to annotate this one NO. This is NO multimeter. That means it is connected across NO and common. The second multimeter is NC. Come fast. Let me keep it here. NC. This multimeter need to connect across common and NC terminal. Okay. So first I will take one wire and will connect it to NC terminal. See, this is our NC terminal. Terminal number 7 is our NC terminal. Then what else? Common. We have a two terminals for common, therefore we are going to use both. That's all. So this, both the multimeters need to be in a resistance mode. Both the multimeter must be in a resistance mode. So that's all. Now we are going to turn on the relay for 1 second and turn off the relay for 1 second. Okay. For that we need to write the coding. See, this is our default program. Can anyone tell what modification I need to do? Shall I use the same program? Yes, we can use the same program, but we need to change the pin number. We need to change the pin number. That's all. Program portion is over. Make the pin number 7 as output. Then so by default, we will do one thing that also we can include here. By default, pin number 7 is low. Then make high, then delay, low and delay. Okay, now we will start simulate and we will check the output. Yes, is it visible for everyone? Whenever, see, my relay is getting turn and turn off frequently, but there is no change in multimeter action. I will tell you one thing. This circuit diagram, this values, whatever the thing we have used, it will 100% it will work for hardware component. Okay, but in this simulation, this, if you add this coil, transistor, then one resistor and LED, mean the coil won't get the sufficient voltage in this simulation part. Therefore, I need to see, I am going to stop the simulation. I'm going to stop the simulation. See, you observe once my program is working. See, relay is getting frequently on and off. Can view this one. LED மட்டும்தான் ஆன் ஆகுது. காயில் எனர்ஜைஸ் ஆகிறதுக்கு கரண்ட் வந்து ரொம்ப மினிமலா இருக்கு. அதை நான் அந்த கரண்ட்டை இன்க்ரீஸ் பண்ணணும்னா நான் என்ன பண்ண போறேன்னா, இங்க சிமுலேஷனுக்காக மட்டும் we are going to bypass this collector resistor, okay, with the very low value. Else we simply will remove this resistor. இது only for simulationக்கு தான். ஓகேவா? பிராக்டிகலா பண்ணோம்னா இது வந்து டேமேஜ் ஆயிரும். So I am going to bypass that resistor alone. Don't remove the base resistor. I am keeping base resistor still available in my circuit. See, take the anode terminal. I'm going to only bypass the resistor, collector terminal alone. Yes. Now we will check. See, now 7. I'll do one thing. Wait. Let me remove that LED. Coil. Yes, we will. So you will remove the LED. Yes. Can you view now? Now I remove the LED indication. Whenever my relay is in on condition, one multimeter will show 0 ohm, another multimeter will show infinity. For better understanding, let me increase the delay. Let me increase the delay 5 seconds and we will check. See, whenever my relay is in on condition means this NO will be in contact. Whenever my relay is in off condition, my NC will be in contact. Please observe these two multimeter values. Alternatively, it will get changed. Can view the output. Can view the output. The transition between NC to NO that you can observe here. Mega ohm means it is the open circuit. 0 ohm means it is a closed path. See, whenever it is on condition, NO will become 0 ohm. Whenever it is off, it will become mega ohm. Okay, likewise, you can check the transition between on and off period. Okay, but practically we won't connect any multimeter. Okay, sir, shall we continue that in next class, or what we can do, sir?
We'll stop here, Gajendran.
Yes, okay. Now, please observe this connection alone and check the multimeter transition alone. What is the continuity between your common and NO terminal? Initially, it is mega ohm. Whenever relay gets turned on, it becomes 0 ohm. See, from the multimeter reading, you can judge my output is, my relay is on or off. Okay. With the help of this one, we will include few more elements in our power circuit in the next class. Okay. So that's all. New component is only relay. It has 6 terminals. It has 6 terminals. These two are common. Sorry, these two are coil terminals. This is common terminal. What this is NC. This is NO. Here in simulation, if you include this portion, the current received by the coil is not sufficient. Therefore, your relay contact may not get properly closed. Okay. Therefore, I skipped this part alone and made the remaining things to work. That's all. Thank you.